All right, so y'all go ahead and do the factoring and math knowledge for today. Pause the video, and then once everyone is finished, go ahead and play it, and I'll go over the correct answers. All right, so this will factor, it's basically an x squared minus 13x plus 40. It's in that form. So if you factored that, you would have x minus 5 and then x minus 8. However, since we have an x to the 4th, we have to make that a squared, and then that'll take care of that x squared right there. Now, those are two differences of squares. Technically, you could factor it as x minus the square root of 5 times x plus the square root of 5, and then also x minus 2 square roots of 2, because that's the square root of 8, and then x plus 2 square roots of 2. But we usually just leave them as integers, and so that will be your answer for today. Okay, looking at the math knowledge question. It's the same information as yesterday. The only difference is this part here. He bought a tenth of the sunflower plants for $15. So first we need to figure out how many plants he bought. Well, there are only 1 pack plants of sunflowers. There are none here and none here. So we have 60 plants. So 1/10 of 60 is 6. And we want to find price per plant. So the price was 15. The number of plants he bought was 6. And if you divide those, you get $2.50. So your correct answer should be E for today. Moving on to lesson 68. We are looking at even and odd functions. We're going to see if we can figure out how to determine if a function is even or odd. Hopefully you'll understand that at the end of this lesson. For an even function, f of negative x is the same as f of x. All of your x's are going to be replaced by negative x, and if they simplify and they're the same function, then that's an even function. For an odd function, f of negative x is going to equal, there's a negative out front, f of x. So whenever you plug in negative x, if it equals the negative of the function, then that's an odd function. And if it's not either one of those, then it's going to be a neither function. It's neither even nor odd. It's either even or it's odd. It could be even, odd, or neither. Okay? The graph of an even function is going to be symmetric with respect to the y-axis. It's always going to be symmetric with respect to the y-axis. So an example of an even function, I'll go over for you, pretty basic one, is a parabola. It's symmetric about the y-axis. And if you take y equals x squared and you replace all of your x's with negative x, well, what is negative x squared? That's still x squared. And so this function here and this function here are still the same thing. And so that's why it's an even function. Because when we replace negative x in our function, we still have the same thing as our original function. The graph of an odd function is symmetric with respect to the origin. The most basic one, let's do a cubic. Y equals x cubed. It may not be the most basic one, but that's a pretty straightforward one. If we replace all of our x's with negative x, well, that is negative x cubed. When we replaced negative x in our function, we ended up with the negative of x cubed. And so that would be an example of an odd function. And it is symmetric with respect to the origin, because if you take this function right here and you rotate it, I'm going to pull some numbers with me, possibly. When you rotate it, it's going to look the same. So that's an example of a function that's symmetric with respect to the origin. When you rotate it 180 degrees, you're going to have basically the same function. So that's what it looks like. All right, so let's look at this example. Is the function an even function, an odd function, or neither? So those are your three options. The way that you do that, you're going to look at f of negative x. So everywhere you have a negative, everywhere you have an x, you're going to replace it with a negative x. So negative x to the fourth plus negative x squared, and then minus 6. Well, negative x to the fourth is just x to the fourth. Negative x squared is x squared, and then we didn't do anything to the minus 6. This looks identical to this function, so therefore we have what kind of function? Even, odd, or neither? Yes, you're correct. We have an even function. Even would be our answer here. Looking at another one. Is this an even function, an odd function, or neither? Well, we're going to start f of negative x. Everywhere we have an x, we put a negative x. So we have negative x cubed, and then minus negative x to the first power. There's a little 1. You can write it if you want. Negative x cubed would be negative x cubed. That negative stays. And then we have minus a negative, so that becomes a positive. Now if you look, this function and this function, they're not identical. So we know that it is not an even function. Now, what we need to do is factor out a negative and see if it is identical without the negative. So if I pull out the negative, I'm going to have x cubed, and then if I pull out a negative from that positive, I'm going to have a minus x. If you cover up this negative here, and you're only looking at what's in the parentheses, this function here is identical to the function up there. So when we put our negative back, we have the negative of our function, and so that makes it an odd function. However, if we had had something like negative x cubed minus x, and we factored out a negative, we have this function here is not identical to the top one right up here that they gave us. So that would be an example of a neither. But this one right here is an odd function. Okay? So now we're going to evaluate this one. And you may be looking at it going, how does that relate to what we were just talking about? How is that even an odd functions? But that's what we just looked at. We know it's an odd function because we just did that on the example. And so when we evaluate this, we could go ahead and use our integration like we've been doing for the rest of the year. However, what we want to look at instead is the graph of it, because the book wants to point something out about this function. If you graph it, it's going to look something like this. I know it's symmetric about the origin because it's an odd function. And I'm going to put negative 1.5 here and 1.5 here. And so if we're looking for the integration, we're really looking for the area. And so we're looking for all of these little pieces here. And the book is wanting you to notice that this area here is the negative area, and this area here is the positive area. But they're the same value because this is a symmetric function. And so those two areas cancel out. And then this area here is a positive area, and this area is a negative area, but they're the same number, and so those will cancel out. And so this integral actually equals 0. And you can test it by actually integrating it, but they were wanting just to point out that you can use even and odd functions to help you with your integrations. Now, I'm sure if you get this on a test or on homework, you may not immediately see it, but with practice, it may start to come to you a little bit quicker. Maybe whenever you see that your endpoints, one is the negative number and one is the positive number, maybe you could try something like that. And especially if there's some function here that you don't know how to integrate, then that would be where you may want to try that. Okay, so let's look at this function. Is this one even, odd, or neither? Well, we always start by doing a negative x everywhere we have an x. So we're going to have negative x to the third and then minus negative x minus 4. And we want to simplify. So that's going to be negative x cubed plus x minus 4. That's obviously not identical to what we had, so it's not an even function. Let's pull out a negative and see if it's an odd function. So I have x cubed minus x and plus 4. Well, is this identical to this? No, because we have a little positive 4, but up there we have a negative 4. So that means it is not an odd function, therefore it has to be neither. Okay, so since this is not exactly the same, even that little bitty sign, that changes it. It is no longer an odd function, it is a neither function. Okay, let's look at another one. Is y equals negative 3 tangent of 2 pi x an odd function, an even function, or a neither? And I don't really know why the book decided to switch around the order of the even and odd, but that's not a hint there. They just decided to do that. So we're going to plug in a negative x into our function. And now we want to simplify that. I went ahead and pulled that negative out. Now this is using the property that we learned back at the very beginning of the year. That when you have a negative here inside of your tangent for your angle, you can actually pull it out front and make it negative tangent of the positive angle. So this is going to become negative 3 tangent, and when we take this negative out, it's going to become a positive 2 pi x, and this negative out front is going to disappear because we're going to have a negative from here that comes with this negative to make it a positive in front. And so we end up with 3 tangent of 2 pi x. So is that identical to what we have here? No. So that means it's not an even function. Is it an odd function? Well, it is an odd function because it's identical except for the little negative out front. And so an odd function is going to be your answer here. Okay, let's look at another example. It asks, are the following functions even, odd, or neither? Well, we need to test by plugging in the negative. So we would have e to the negative x. There's no way to really simplify that. I mean, we could write it as 1 over e to the x, but that doesn't really help us. This is not identical to what they gave us, so it's not even. If it were going to be an odd function, we would have ended up with negative e to the x. That's not what we have here. So this f of x is a neither function. It's neither even nor odd. Looking at this one over here, g of negative x is going to be e to the negative x squared. So if we simplify that, we would have negative, and then this part here is going to go back to an x squared. Well, that's identical to what we have to start with, so that is an even function. So we've got one neither and one even there. Let's look at one more example. Is this an odd, an even, or a neither? So we start by replacing with a negative. So we have negative x squared, and then plus cosine of negative x, and then all over the sine of negative x. So we know that negative x squared is just x squared. The other two parts are again using those trig parts that we learned at the beginning of the year. So cosine of negative x is just cosine of x. Remember, cosine and secant are the two that when you have a negative for the angle, the negative can just go away and you're just left with the cosine of the positive angle. And then sine is just like the tangent that we talked about a minute ago, and so it will be negative sine x. So instead of cosine of negative x, we would have just cosine of x, and then divided by negative sine of x. So if you look at that, it is not identical to what we were given, so it is not an even function. We know that to start off with. Now we need to figure out if it's not a function, or if it's neither. When we have negative 1/2, we can take this little negative and make it negative 1/2. And that's what we're going to do with this negative right here. We're going to make it negative x squared plus cosine x over the sine of x. And if you look, everything in the parentheses is exactly like what's up there that they gave us, and we just have a negative out front. So that means that it is an odd function. Okay? All right, so your homework, you do get to omit number 10. So I want you to make sure to do that tonight so that we can go over it tomorrow and you can answer any questions that you have. But that's basically all there is with even and odd functions for this lesson. So hopefully that's not too bad.